Hello everyone, welcome back to Data Programming 1. I hope you all are doing well and staying healthy. Today we have lecture 37, databases 3, only a couple more lectures left in the whole semester. Today we're going to be looking at the connection between pandas and SQL. Let me start off with a couple of brief announcements. First up, P10 is due next Friday, and just a reminder that late days may not be used on that assignment. We need to make sure that we can get everything graded on time to turn in grades for the course. There was an email that came out from Mina about the point redistribution. So we've canceled exam 2. We've changed the final exam to a final project. And as a result of that, we needed to change how many points are allocated to each of the projects so that they add up to 100 points in the end. And when we did that, we didn't want to actually increase the weight of exam 1. It started at 15%. We want to keep it at 15% of the course. For those people who did very poorly, we didn't want to suddenly make it worth a whole lot more. We also didn't want to make the final project just worth the equivalent of exam 2 and the final exam. So we rebalanced everything. There's an email that came out about that. To make the math all work out really nice and neat, we gave everybody just 3% free points. So enjoy. And if you have any questions about the new point allocation or how you need to pass or how well you're doing, definitely send me an email and I'd be happy to take a look at that. All right, next up, the final project. Our goal is to have that released by the end of the day on Thursday. It's actually 5:10 on Thursday right now, so it probably really will be the end of the day before I get that into any sort of good shape. So look for that coming this evening. There's a Google form available for grading, resubmission, and deadline extension issues. If you have any of those, use the Google form so they don't slip through the cracks. We don't miss an email. Let's see. Course evaluations are now available. I'm actually applying for a full-time job for the fall with the University of Wisconsin. So I would very much appreciate if you guys could take the time to fill out the evaluation for me. If you think I did a great job, let them know. If you think I'm doing a terrible job, also let them know. Just be honest. And they're definitely going to be looking at my course evaluations for this semester. So I appreciate you guys taking the time to do that. Next up, there's a possibility that both Mina and I will be teaching courses during the summer. And all courses during the summer at the university are going to be taught online. So I just have a question for you guys. You guys are all taking other classes. You're busy doing lots of things. We all know that. What are the professors in other classes doing that's working well for you? And in particular, I have a question about if anybody's taking these larger classes, with hundreds of students, are they using, what are they doing for final exams? What are they doing for exams in general? And is it working well or is it a horrible disaster? I want to make sure I avoid horrible disasters if at all possible. And if there's something that works well, I'd love to hear about it. All right, and finally, the feedback on my last lecture was actually really, really positive. There were 10 people that either commented on YouTube or sent me a personal email saying they really liked the interactive style. I didn't really do a traditional lecture, but instead more or less created a high-tech worksheet using Jupyter Notebook. And I'm doing the same thing again this time. Yeah, let me switch over to our webpage here and talk about what we're doing today. I've created another high-tech worksheet. This is another Jupyter Notebook with some questions to guide the learning process today. I gotta admit, lecture is a great way to reach a lot of people all at the same time and give them some information, but it's truly a terrible way as a student to learn how to program. I've said many times the best way to learn this stuff is by doing it. So what I want to do here is create an opportunity for you guys to actually get some practice doing some programming and to think deeply about these concepts. So let's get started by taking a look at this worksheet. Pull this up. If I click the link, it takes me to our GitHub page. There are 3 files here. There's the lecture. This will be the file that I fill in. It's actually the exact copy of the worksheet, which is the questions that you guys will be working with. And then, I just pointed the wrong one. This is the database. This is the data we'll be manipulating today. We'll be asking SQL questions and pandas questions about this. So this is the one you guys will fill in. This will have all of my answers at the end. I've already downloaded them. I've got them in a folder here. And let's just take a look at these. So actually you can see they are, let me scroll up to the top, exactly the same. This is the one I'm going to be using when I fill in the questions to the lecture. You guys use the worksheet one. All right, let's just take a look at these questions to get us started. They all pretty much look like this. Without running the cell, predict what's going to happen when I run this statement. This happens to be a pandas statement. So we'll predict the outcome when we run this. And then the second part of this is convert this statement into SQL. If we look at question 2, it says predict the output from this SQL query and then convert it into a pandas statement. We've actually already learned everything we need to do all of the questions in this notebook. It's a lot of really great review. I will be introducing one new topic, value counts, but you can do the worksheet using a bucketize function instead if you want. Value counts is faster to write and definitely worth learning. And I'm also going to point out a lot of the connections between SQL and pandas. There's a lot of value in learning these, and figuring out one of them makes the other one easier if you can see these connections. So my plan for today is to just go through these questions, break them down, answer the questions, and then draw these connections between the pandas and SQL languages. I recommend you guys actually pause the video and start doing these questions on your own. And then I'm going to be, as I do these questions, I'll be putting a timestamp in the description where I start and finish each question. So if you run into any trouble with some of the questions, you can watch that section of the video. If you've got the question, definitely just skip that part of the video. In fact, you will know the right answer to all of these because you can just come back up here, you can delete the comment, you can run this line and see exactly what's produced. No longer do you need to just predict it. All right, so let's start going through this and just taking a look at what's in the notebook and to remind ourselves what's going on. So this very first cell is just for styling for YouTube. I'll make it a little bigger. So it's going to let us use the entire width of the screen, and it's going to let me color some of the things in red in my questions in a little bit. All right, we're looking at SQL and pandas, so I'm going to import both of those modules. And then to bring in my database, it's a SQLite 3 connect that will create this connection object. So I'm going to run this, and now I have a connection object. And from there, I can use that to bring in the data. It brings in the data and lets me do SQL queries. I've got a function here just like I used last time, so I can focus on just writing the SQL query without having to do any of the extra pandas.read SQL. Remember the connection. This is a global variable. So it just lets me write queries faster without having to deal with the extra overhead of syntax. Let me run that to establish that query to define it. And then let's take a look at this. The very first thing we'll ever do when we look at a new database is actually read SQL and select from SQLite master. And this is going to tell us stuff about the data in the database. Okay, so this is telling us that we have 3 tables. These are all data about the city of Madison. In this case, we're talking about where all the fire hydrants are located. City of Madison keeps data on absolutely everything. And they have a database about all of the trees that they maintain. And then we have a little index here about the species of trees. And this is just a subset. I've just grabbed a couple of these so we have a small, reasonably sized data table that we can look at. All right. So the next thing I'm doing is I'm actually going to be grabbing, so remember a SQL query actually produces a pandas data frame. And so that I'm just running some queries here in this cell and assigning these data frames to different variables. So I'm going to get all the hydrant data from the table in the database and storing it to a data frame. The tree data table, storing it into data frame, and the same thing with species. So let's just take a look. Let me run this, and then let's just take a look at these. So first up, if I take a look at the hydrant, it's got some information about the fire hydrants available in Madison. The year they were installed, what color they are, the style, whether they're public or private, an ID, whether they're in use or not. Okay, so some data about fire hydrants. The trees, every tree is given a name or a code. It's got XY coordinates. It's got a species code, and then some data about it, the diameter, and whether it's important to the city or not. So they need to make decisions about whether they're going to come down and do trimming or if they're going to cut it down and replace it. And so some of the trees are more important than others in Madison. They've been given a priority. And then if we take a look at that last species item, this is just going to tell us that the code M in the tree stands for maple and the code P stands for pine. Okay, I'm going to pull back up that tree one because the very first set of questions here is all about this tree data set. Okay, so I'm going to pause the recording so I can get a timestamp, and then I'm going to do this very first question. So just taking a look at this very first pandas statement, the first thing I can see is a whole lot of square brackets. We've actually got 4 pairs of square brackets, and every single pair of brackets is used for a different purpose. So I'm going to copy this. I'm going to pop over into PowerPoint where I can color code everything and make some slides so we can talk about this. Be right back. Alright, so I put together some PowerPoint slides to talk about this first one. So I've got the data table here about trees, just so we can refer back to that. And then I've copied the statement here and color coded all of the brackets. When we use brackets or anything in more than one way in programming, that's known as overloading. And here we've got 4 different situations we're using things. So first up, what I'd like to do is look at the innermost one first and then work my way out. So I've got these color coded. So you can see here we've got the blue brackets, and then inside of those are red. And we have another pair then, the purple has green inside of them. So we've got sort of this like divide right here. I'm going to take a look at the left half first, and then we'll come back and look at the right half of this. So this left half is going to reduce down to a data object. Every time we're using the brackets here, we're accessing the data in a particular way. And that's going to create a data frame. And then over here, we're going to use these brackets to access that resulting data frame that we get from all of this stuff. So let's take a look at the red ones first. So the red ones here, when I have just one thing inside of a bracket and trees is a data frame, what I'm doing is accessing a column of that data frame. So in this case, it's grabbing this priority column right here. So trees, bracket, priority, gets me a column. And this is going to return a series. So I just get the data, 71, 100. The numbers here are the integer positions. All right, so that's what this is doing. The next thing I'm going to do when I take a look at this outside pair, the blue brackets, what's inside that is this series generated by accessing the priority column. I'm going to be comparing that to 90. This is an element-wise comparison, and this is going to generate a Boolean series. So in this case, is the priority greater than 90? 71 is not greater than 90, I get false. 100 is greater than 90, that one's true. Okay, so the next thing I'm going to do is I'm going to take a Boolean series inside these blue brackets. So this is my series. And when I add a Boolean series inside the brackets, what this is going to do is filter by rows. So if I take a look at the result of this, I should get row 1 and row 4. So row 1 here is the one with priority 100, and row 4 is the one with priority 99. So B and E. And this should give me the full table, all of the columns, but only those 2 rows. Okay, so when I actually run this, that's in fact what I really do get. I get row B and row E. So this entire left half here is just selecting down the 2 rows that have priority greater than 90, B and E. All right, let's take a look at this other half now. So inside the purple braces, or the innermost one, that are actually the green braces. These green braces are actually creating a list. So when I do this, Jupyter Notebook tells me here's my list. The type is actually a list. And what I'm doing now, this left half was giving me a data frame. Let me pop back up. This is a data frame. And when I access a data frame using a list, what it's going to do is select these 2 columns. So it's going to give me the X and the Y columns of that data frame. So I've got a data frame. I'm using a list to access it. Here's the full statement. And now it's going to give me the X and Y columns from that. All right, so let me pop back over into Jupyter Notebook and put this together with the actual data that we're looking at here. Okay, so the first thing we're doing is we're selecting the 2 rows that have priority greater than 90. That's what this whole left half does. So I'm going to get row 1, where the priority is 100. So that's going to have B, 20, 4, M, 10, and 100 in it. And we'll also get this bottom row, which is row 4, E, 54, M, 12, 99. All right, and then the left half of this, let me put my headings in too. We get tree, X, Y, species, diameter, priority. Make it look good real quick. Okay, so then that's what we get from the left half of this, that much right there. Then this is going to create a list and use that list to access this data frame. So this is my resulting data frame. The list here is just going to select this column and this column. So I no longer care about the tree column. Let me get rid of this. The X and that in the back in the right spot. And then we no longer care about this or this or this. So the end result of this statement should be something that looks like this, a data frame like that. So let me comment this out. Comment. We'll put this back. We'll run it and we'll see how close I got. Yep. And I want to point out too here that the indexes that it kept, this is the key from a dictionary. If you remember back to the Pandas lectures about data frame, these are retained. So this is at integer position 0. This is at integer position 1, but the index is retained from the original data frame. So index 1, index 4. And there's lots of different ways we can access the pieces of this. Just we've seen a couple of them. We've accessed a column using just the straight square brackets. If we wanted to access a particular row, we could use location with the index of the row, the dictionary key style one. So this would be at index 1, and that would be with the dot location, dot LOC. If we wanted to use the integer position of the row, I could also use ILOC, or integer location, and this would be 0. So now let's take a look at the second part of this. All right, so first up, let me give myself some more space. We'll do that. We can still see the statement. And now the idea here is we want to convert this to an equivalent SQL query. Let me pull up my data table right here while I write this. Run that frame. Why is it not printing this out? It needs to be code. Then I can run it. Okay, there it is. All right, so here's my data frame. What I want to do is write a SQL query that will extract just the trees with priority greater than 90. So this is going to be query. Whoops, got some extra stuff in there. And now when I write a SQL query, I need a certain, all these keywords, and they've got to be in a certain order. So the two that are essential, I must always have a select and a from. So I'm going to be selecting, and I want columns X and Y, and I want them from my data frame trees. Was that the name of the data table, or was it tree? Nope, definitely trees right there. Okay, and then I also want to select just some of the rows, a subset of the rows, and I want rows where priority is greater than 90. All right, I think that should be good. Let's give that a try and see what we get. Perfect. So it was way simpler to write this in SQL, and I think we'll find that to be true for most of these. All right, let's take a look at this next one. So first thing I'm going to do is pull up my data table so that I have something to look at as I'm going through so I can make a better prediction. And then as I take a look at this, I've got it all in one line. There's no reason, I've been putting all of these things on separate lines to space them out and think about them. But no reason they can't all be just in one line. So I'm going to have three keywords here. First, the most important one, it tells me which table, so from trees. And then the next thing that happens is I'm going to be selecting, using where, just some of these rows, and just the rows with the M. So where piece is equal to M, I'm going to get this row, so row 0, I'm going to get row 1, and I'm going to get row 4. So that's going to grab just those 3 rows. And then finally, I'm going to be selecting just one column. So this is going to be a new column. It's not one of the columns in the table. It's going to be a column created by taking the X value and adding the Y value to it. And it's going to be called X plus Y when I'm all done with this. So what this is going to look like is I'll have a new column, X plus Y. That's the name of the column. And then I'll be taking the rows that have an M and adding them together. So 10 plus 4 is 14. And then the next one here, 20 plus 4 is 24. And finally, the last row, 50 plus 4 is 54. And now it's creating a new data frame. So that's going to give me also indexes. These are just created because it's creating a new data frame. So I'll get those. There's the column header. So this is what I should be looking at the very end, something like this. All right, I'm going to go ahead and put some comments in here. Whoops, stop that. Oops, I clicked insert. There we go. All right, that looks good. I no longer need to care about the trees, and what I want to do is bring this back up and make sure that I'm right. Okay, looking pretty good there. Now, let me pause the video so I can get a timestamp. All right, so converting these SQL statements into pandas is one of the most challenging parts of this homework, and this one's no exception. So I'm going to go back over to PowerPoint and talk about problem 1 a little bit, and how we can talk about how each of these individual pandas parts correspond to a particular keyword in SQL. I'm going to go make some slides. I'll be right back. All right, so I've got a new PowerPoint slide put together to talk about this. How the different pieces of pandas correspond to the different keywords in SQL. So this is problem 1 here. We just took a look at this, and I thought this would be appropriate to talk about how we did basically the equivalent of where. So when we did the tree problem where we gave it one keyword that selected the priority column, we used the Boolean series by comparing this to 90 to select certain rows. This is the equivalent of a SQL where statement. This was way easier to write in SQL. All I needed was the word where, priority greater than or equal to 90. But this is the pandas equivalent of that. So we're going to need the same thing for problem 2 because we're selecting rows where the keyword is, where the species is M. So this gave us just the rows. And then the second half of this was a lot like the select. And we're going to need something very similar. Here we selected the 2 columns to create a new data frame, X and Y. All right, let me do Jupyter. And what I'd like to do here is convert this to a pandas statement. So let's do this in a bunch of pieces. So first up, let's get a look at the table. So the first thing I'm going to do is select just the rows where things are equal to M. So trees where of species, this much should give me the column. So this will be a sequence with all of those pieces. What I want to know is where trees of species is equal, and this is pandas, so I need the double equal M. And now this is a Boolean series, and now I need to stick the Boolean series into this statement to extract just the rows. So this is I'm accessing the data frame and selecting the rows with the Boolean series here to get a new data frame with only the rows where I have an M. Okay, so far so good. The next thing I want to do, so this is the where part of my a SQL statement. So the next thing I need to do is I need to get columns X and Y. So to do that, to extract a single column, I'm going to use another pair of brackets. This will give me the X column. So there we go, 10, 20, 50. And finally, I need to add that to the Y column. So I'm going to just copy this, paste it again, and this will be the Y column, lowercase y. Okay, now this is giving me 14, 24, 54. So the only thing I haven't done here is create a brand new data frame with the renumbered indexes, but it's extracted the same data. I think I'm going to leave the re-indexing to a different problem. It's not really where I wanted to go with this. I just want to be able to convert the data into the same thing. All right, let's take a look at the problem 3a now. In this case, we'll be predicting the output of these 2 pandas statements. So the first one, I'm creating a variable CD and stashing whatever the result of all of this is. Let's take a look at this. So the first thing, there's actually 3 parts to this. So I'm going to be extracting something from species. Let me pull up species real quick so we can take a look at the data. So the first piece of this, I'm going to be grabbing one of the columns from the species data frame, and it's the code column. So this will be a series. When I'm done, I'm only grabbing one piece, one column. So it'll be a pandas series with an M and a P in it. The next piece of this, I will be applying this to that series with the M and the P. And what this is when I see that double equal there on the inside of this, it's going to be giving me a Boolean series. So I'll be selecting some of the rows from the series that has the M and the P in it. And those are just the rows where the species column, this column, so this much right here grabs a new pandas series with maple and pine in it. And it's going to give me a Boolean series with true and false, because these are equal to maple. And then finally, last thing I'm going to do is from the result of all of this, I'm just going to take whatever is in the very first position, I location 0. So let me walk through this a little bit. This first part right here is going to create a pandas series with an M and a P in it at position 0 and 1. Okay, let me give me some space. And then this second part right over here is gonna, let me do just this much right here, is gonna grab a new pandas series with maple and pine in it. Okay, and then it's gonna compare them to maple. If they're exactly equal to maple, it's gonna be true. And if they're not, it's going to be false. So we'll get a new pandas series, a Boolean series this time with true and false. And then when we apply this to access the data found in this series, we're only going to retain the rows that have true. So I'll get row 0 that just has an M in it. All right, and then I'm going to grab whatever is in row with integer position 0. That's just this character right here and store it in CD. So CD is going to contain the character M. All right, let me go ahead and uncomment this row. And comment these other things I'm not using. So we'll grab CD and we will show that it is indeed the character M. Okay, great. I'm going to keep this here. I'm going to bring, I'm done with species. And now I'm accessing a lot of stuff from trees. So I'm going to bring up my tree table. Trees table. So I can take a look at this. So the next thing I'm going to do is, as I go through and analyze this part of things, let me see here. So I'm grabbing something from trees. The thing I'm grabbing from trees is a Boolean series. So this is going to be selecting some of the rows. And the rows I'm grabbing are, first I'm creating a pandas series with the species. So that's going to grab this series right here. It's going to have 0M. At position 1 we have an M. At 2 we have a P. At 3 we have a P. And at 4 we have an M. Yep. Okay, and it's going to ask, are they exactly equal to M? And if they are, then they'll be true. True, true, false, false, true. Excuse me. Capital true. Now, when we take a Boolean series and apply this to trees, it's going to just select the rows where they're true. So rows 0, 1, and 4. And finally, the last piece of this, it's now created a new data frame with these 3 rows. So it's going to look something like, I wonder if I can just do this. That's not bad. So 0, 1, and 4. And then it's going to come back and it's just going to grab the tree column. So that's going to be just A. We'll get rid of the rest of this. Just B. And just E. And because it's a data frame, I'm selecting things, we should still see the 0, 1, and 4. All right, let me comment all this. And then we will run the code and see how close I am. All right. Excellent. I didn't make any mistakes. All right, cool. So let's take a look at this, how to convert this into a SQL query. I'm going to push pause so I can grab a timestamp easily. All right. So as we begin looking at how to convert these statements into an equivalent SQL query, let me just add a new cell here. I'm going to copy these down below so that I can see them all. And we'll just take a look at them. So one at a time. We'll do the CD part first, where we were grabbing the M from the species table. So just quick reminder, species has this stuff in it. And what we're doing is just putting in the keyword maple and grabbing the M. So an equivalent SQL query would look something like this. I'm going to do query and then select. And what I want is the M column. So I'm going to be selecting code from, it's the species table, and I want to where, oops, this isn't capitalized, where, and in this case I want species equals maple. All right, and I'm using single quotes around maple because I'm using double quotes around my entire query. And I think that should do it. Okay, excellent. So that's progress. Now what this is returning is actually a data frame where I want to still extract the M here. I want a character and I want to store it in a variable CD, so I'm matching the Panda statement. So to do that, I'm going to first grab the code column, and that's going to create a Panda series. And then what I want to do is grab the very first element from that. So dot I location, we'll grab the 0th row of it, and that should give me CD is equal to, print it out, just the character M. And just to verify, type of CD is indeed a string now containing M. Print CD and type of CD. All right, looking good. So now I've got the character M and stored in CD. So that's the first line of this. All right, with that extra little trick to extract just the character from a data frame. The second part of this also requires a little bit of a trick. This is the one where if I were to just do this, let me pull up trees. I don't need that anymore. I can come back to it. So here's my tree table. If I were to just do this the way we did before, I'm looking to grab just the names of the trees that are maple trees, or just with code M, A, B, and E. So let's do this in a couple steps. I'm going to do a SQL query, so I'm doing query. I'm going to need a statement. It'll have a select, a from, and a where. And if I want to do this the easy way, I would be selecting the tree to get the A, B, and E from trees. And then finally, the where would be where species is equal to, in this case, letter M. So that should give me the answer. I did something wrong. What did I mess up? Ooh, extra quote. Yep, that should be the answer I want. Now the trick comes in where I don't want to actually put the M in. I want to use this variable CD. Okay, so the first thing I thought I should try is, let's just add a CD right here. This gives me an error though. And if I read down to the bottom of this, it tells me the execution failed, not SQL, no such column M. Well, what it thinks it's doing is something that looks like this. This is what it's actually doing. It's putting the character M in my string when I really want this little M to be in quotes, because I need to give text to the SQL query. So I'm going to leave those little quotes there, and I'm going to use my string format function to fill in the letter M right there. Dot format CD, and now that'll take the contents of the variable CD, which is the character M, replace these brackets, and they'll be inside the single quotes right there. All right, and that gives me the same data table back as I saw up here using SQL, with the exception that I'm not bothering to re-index things. And here's the trick right here, is to actually get a variable from a a character from a variable into a SQL statement inside the quotes. I needed to use this either format, or I could use the string concatenation with the plus, but I do need to have the quotes. All right, let me pause right there, grab a timestamp, and we'll move on to the next one. Okay, this is another SQL statement, and it looks like we're looking at the tree table. So let me go ahead and pull up trees so we can look at that while we're going through this. All right, we'll be selecting species from trees, and we're going to order by priority, and we'll be in descending order. Okay, So let me do one thing real quick here. I'm going to give us some extra information. We're only going to be selecting species at the end, but as we go through, we'll be ordering by priority. So I'm just going to keep track of that. So as we select by priority, 100 is the top. So I'll have a priority of 100, and the species of that tree is M. And then the next one is 99, also M. And then 71, also M. And then we have a priority of 40 and 30. Both of those are P. Okay, now we're not actually selecting this priority column. Instead, we're just selecting the species. So let me remove all of these. And then, because when I do a query, it's returning a data frame, these will have indexes automatically added to them. And it'll look something like this. Let's see here. And then this column will be labeled species. Species. I can totally spell it. There we go, species. And yeah, that looks pretty good. Maybe one more. Yeah, that looks really good. Okay, so that's what we expect to get from this. Let me comment this and then just run this statement and verify that I didn't mess up. Okay, looks good. MMMPP. So it kind of looks like the city of Madison prioritizes their maple trees over their pine trees. I'm not too surprised pine trees grow so much faster that if I wanted to replace one, chopping it down and replacing it would be much quicker. Maple, on the other hand, not quite so quickly. All right, that got off in a tangent there. Apologize about that. Let me stop the recording, grab a timestamp, and then we'll convert this into a pandas statement. Okay, so the next thing we're going to do is convert that SQL query into pandas code. So let me grab a new, here we go, a new box, a cell to put this in. So the first thing we needed to do was we're going to be sorting by priority. All right, to sort it here, let me take a look at the data frame. There's the data frame. In order to sort a data frame by priority, the command in pandas is, don't screw it up, Mike, sort values. Okay, and I need to give it the name of a column here. Priority. Let me verify that works. Yes, okay. So now I've got them sorted by priority, 30, 40, 71, 99, 100. They're in the wrong order, though. I want them to be sorted descending. So the keyword there, I need to give it a keyword variable. Ascending equals false. And now they're reversed. I don't remember talking about this in my other lecture on databases. I apologize if I overlooked this. I can go ahead and look up sort values. There's lots of keyword variables I can put in there to control how this is going to work. But this is sort of the overview. These are the important things. Which column I'm sorting by, and ascending or descending. Here's how I do it in pandas. Okay, the last thing I want to do, this creates a brand new data frame. Here it is. But I don't want the whole data frame. I just want the species column. So I'm going to access the data frame with square brackets and grab species. There we go. So it still messes up the indexes. It's creating a new data frame, but it's retaining those indexes. I'm not going to worry about that for this lecture. We're not going to worry about re-indexing anything. All right, so taking a look at number 5, we are doing another SQL query, and it looks like we're going to be extracting from trees. So let me take a look at my tree data table. So the query says we'll be selecting tree, that's this column right here, and priority from trees, and we're going to be ordering by priority, and then descending priority, so 100 will be the first one, and then I'm going to limit myself to just one row. So this is going to give me, let's see here, the tree and priority. We'll get 2 columns, and let's see here, we're going to get the tree with 100 priority first because we're sorting them. So that's going to be tree B, priority 100. And I'm just going to stop here. I'm not going to write the rest of these because we're limited to 1. So that's going to be everything inside of here. So this will be a data frame. So I'll get row 0. And that's what this is going to look like. The next thing we're going to do is we're going to be turning this much and just grabbing from the data frame row 0. So that's going to be a pandas series, and I'm going to turn the pandas series into a list by using the list command. So at the end of the day, I'm going to get b comma 100, a list with 2 items in it. All right, let me comment these out and demo that it really works. Please work, please work. Okay, sweet. Yep. So, all right, next up, converting that. Let me grab a timestamp. Then we'll convert it to pandas. Okay, to grab the highest priority tree from the data frame, or data frame in pandas is a little tricky. Here, let's go through this. I'm going to add a new cell. So the first thing we need to do is sort them all by priority. So I'm going to take trees. Let's just take a look at this. And we'll do sort values by priority. All right, that's going to give me the sorted data frame. Now I actually don't want it sorted in that order. I want the reverse of that. So we'll go with ascending equals false. And there, now they're sorted in descending order. So the next thing I want to do is I just want the name of the tree and the priority. So from this, I'm going to access that with square brackets, and I'm going to be using the list access version. So inside my square brackets, I'm going to create a list, and I want the tree name, tree, and the priority. Let's make sure that much works. Okay, so now I've got tree and priority. And from here, all I want to do is extract the very first row. So that's, and because I want the first row, I'm going to use integer position, or iloc, integer location, with row 0. And I need square brackets on that one. There we go. And now this is giving me a pandas series with tree and priority as my keys, or indexes, B and 100. So to convert this to a list, same thing I used up here, right there. Let's just turn this into a list like that. Okay, cool. Let me grab a timestamp. All right, this next one's actually pretty easy. So first thing to notice, we've got the keyword select here. And then the next command, the next keyword is from. So both of these, the count species as C1 and let me do this, count distinct species, are both going to be the columns that we're selecting. Now, we're using count here. That's going to be an aggregation of the data. So here, and it's from trees. So first thing I'm going to do, let's pull up the trees data frame and take a look at it. And what we're going to get is a new data frame, because queries always return data frames, with 2 columns. They're called C1 and C2. So C1, C2. And what's in C1 is a count of all of the species. So it's going to grab the species and then count them. 1, 2, 3, 4, 5. So that should be a 5. And then the next column is going to be counting distinct species. So it's going to say there's 1 M and there's 1 P. Those are the 2 distinct species, so it should get 5 and 2. It's creating a new data frame, so this should be row 0 of my new data frame. And we should see, let me just check the answer. Yep, row 0, 5 and 2. All right, cool. All right, now for the second part of this. Converting to pandas is always a little more tricky. Let me just grab a new cell here. And this is where I want to introduce the idea of value counts. This is something I overlooked when I was going through data frames. But let me introduce it right here. So if we have a pandas series, I'm just going to call this X pandas series. And we'll go ahead and create this series from a list. And then I'm going to add in some characters. And we'll have, let's go with A, B, C, A, B, A. Okay, so here's the idea. So let me run that. Let me print out X. There we go. Here's my pandas series. one of the things that pandas provides me is a function called value count. Value count. There we go. When I run this, value counts, plural. Nope, typos. Failing. Value counts. There it is. What this is going to do is it's going to create a pandas series. Here, let me just show you that. Type of that is a pandas series. All right, let me pull this back up so we can take a look at it. And what it's doing, the index values are the data entries that I had in my list here. And the actual value, so this is the index, the value is the number of times they appeared in this list. So there are 3 A's, so the value is 3. There are 2 B's, so index B has a 2. All right, so this is what I'm going to use when I replace my count distinct species up above. So let me just grab a new cell here. Below this one. I'm looking at the trees data here, and what I'm doing is counting the whole number of species and counting the distinct species. So let me do this in a couple of steps. So first, I've got the trees, and I'm going to extract the species row from it. And then I can just grab the length of this with the length function. Okay, so that's going to be the total number of species in there. I'm going to do something very similar. So we'll get trees species. So this is again going to be a series extracted from that data table, data frame. And what I'm going to do now is call value counts on it. And see that I have 3 M's and 2 P's. But what I really want to know is how many of them, how many rows are in this data frame. I'm sorry, series. So length of this should give me 2. Okay, excellent. So now I've got the total number of species and the distinct number of species. And the last thing I need to do, if we look up here, this was returning a data frame with columns C1 and C2. So I'm going to need to create a new data frame. Pandas data frame. And now when I create a data frame, I could use a list of lists, I could use a dictionary of dictionaries, a list of dictionaries, a dictionary of lists. So in this case, what I'm going to be doing is a list of dictionaries. And in this case, there's only one row, so I only want one dictionary. I've got C1 and C2, and the value is going to be, let's see, it's this stuff right here. So C1 is that, C2 is this, and I also need quotation marks. Okay, so that's a lot of stuff, a lot of parentheses and brackets. So I'm creating a data frame. It's a constructor, so I've got the parentheses here. I'm using a list which contains one dictionary, and that dictionary is going to give me that first row, and I've got 2 elements. So this will be the, whoops, don't move it around. This will be my column index, and this will be the first value. This will be the other column index, and this will be the value. Looks like I lost a comment. Let me just run this and make sure it's looking good. Yep. So this should be exactly the same thing we have there. All right, excellent. Okay, next question. So I've got a SQL query here. First thing I'm going to do is rearrange this a little bit so that all of my select things are on the same line. It's going to look something like this. From trees, and then group by species, and now order is going to get its own line too. So there I've got all of my SQL commands on their own line. All right, let me pull up the data frame because we're looking at trees. So the first thing we see is we're going to actually be, we're not eliminating any rows here. Instead, we're doing a group by and grouping by species. So this will grab and basically make essentially 2 new data tables, one with all of the M species and one with the P for pine. And then we're going to count them. Well, here we're going to create a new table, a new data frame with 3 columns, one for species, one for the count of the species, which we will be naming count, and one for the average diameter, which we'll be naming size. So in the end, we're going to get a new data frame. It's going to have species, count, and size as the columns. Okay, we've got two species. We've got M and P. And then we're going to be putting in count. Hold on. I pushed insert again. M. Count. We have 3 of those. P, we have 2 of those. All right, we'll be ordering by count descending. So we're already there. I didn't need to switch it. And last up, the size is going to be the average diameter. So if I take all of the, here, let's do 8 plus 10 plus 12 is 30. So the average is 10. And then 6 plus 8 divided by 2 is 7. All right, so that's my prediction. Let me go ahead and comment these out. We'll run it and we'll see if that's what it really turns out to be. So uncomment the code, we'll run it. All right, count 3, size 10 to 7. Oh, I did leave out my indexing rows. 1, 0, and 1. There we go. All right, very good. Now let me see if I can figure out how to turn this into pandas. All right, so I gave this a little bit of thought about how to convert this code into pandas. Decided this is a little bit beyond what I want to do in this course right now at this point. I'm not going to introduce any more new functions, and to do it using the stuff we've already learned is a lengthy process. So I'm going to leave it out there as a challenge for those of you guys who are looking for a little bit more in the course, and just move on. But this one's definitely not required. You're not going to see anything like that in the rest of this course. Okay, I also have a number of additional exercises here using that fire hydrant data set. More of the same. And again, you guys can do all of these on your own. Pull up the fire hydrant data set, see if you can predict what these queries will do. You can run the query to get the answer, and then try and put it, so this one's in SQL, try and write a pandas version of this. And of course, you'll know when you get it right, because it'll actually be the same output. All right, I think I'm going to wrap things up right here. The sun came up a while ago, and I need to get this lecture out for everyone. So have a great day. Stay safe. If you have any feedback about this lecture, definitely drop it in the comments. That seems to be very popular. You can send me an email, or you can use our feedback form on the webpage. Have a great day, everyone.